For these two examples, we're going to let our calculator find the answer for us, rounding to 2 decimal places. So I've put 2 examples on here that even though we think we can use our calculator and it's going to be a pretty easy answer, it's not as straightforward as you think. Now both of these problems that I'm asking you to solve use are not going to use the normal sine, cosine, tangent, or inverse sine, inverse cotangent, inverse cosine, and inverse tangent functions, because I think you know how to enter in an angle, hit second sine, and you get the inverse functions, and you'll see that those are pretty straightforward. So I wanted to focus on those 3 that are not on the calculator, being inverse secant, inverse cotangent, and then there's also the inverse cosecant. So how do we enter those onto the calculator? Well, let's start by looking at, first of all, this example here. We want to know what is the inverse secant of -4. Since secant and cosine are inverses of each other, the way we would enter this into the calculator is going to take advantage of that. So on the calculator, we're going to use the inverse cosine function because these two are reciprocals of each other. But instead of taking the reciprocal of cosine, we actually take the reciprocal of the angle when we enter this into the calculator. So if I want to know what so I would enter it into the calculator like this, 1 over -4. So I'm going to use the reciprocal identity, cosine inverse, but it's the angle that I am actually reciprocating. So we're just going to plug that in. So I have second cosine brings up my inverse cosine function, and I have -1 divided by 4, hit enter, and it returns for me a value 1.82. Okay, so approximately 1.82 is the answer when I take the inverse secant of -4. So kind of straightforward as far as just that kind of an answer or that kind of a solution. Let's look at cotangent, however, and we'll kind of refer back to what we just did in a second, but let's look at inverse cotangent. I want to point out to you that the calculators are, they know what the range is, what the allowable range is for all of these inverse functions. And we need to kind of look for a second at inverse cotangent. Inverse cotangent's range, or the answer for inverse cotangent, lives up here in quadrants 1 and 2. But we just kind of got through saying that in order to find the inverse cotangent on my calculator, I'm going to have to utilize the reciprocal identity, which says I need to find the inverse tangent of 1 over the angle, -0.2528. Before I go punch that into my calculator, let me point something out to you. Inverse tangent lives over here in quadrants 1 and 4. So when I take the inverse tangent on my calculator, it's going to return an answer for me somewhere over here. And since it's negative, it's actually going to return an angle that is down here. When I need the inverse cotangent of a negative angle, which is technically up here. So we need to kind of take into account for that for just a second. So let's just do inverse tangent of this angle on the calculator. And let me scoot this over. So we're looking at second tan gives me the inverse function. And we have, we have 1 divided by -0.2528. When I hit enter to 2 decimal places, I get -1.32. Oh, but hold on one second. I don't have this on the notes, but we're going to do this one more time. I don't want to be in radian mode, which is what I am here. I am going to use degree mode. In other words, this is a degree value. So we're going to go back in and we're going to do that one more time. I need to be, and I have to tell you specifically that we're talking about degrees and not radians, and so I'm telling you now. Let's go back and try that one more time. I want to do the same function, only I need to be using degrees and not radians. So I'm changing it on my mode. I'm going to come up and I'm going to pull that problem down one more time, and I'm going to ask the calculator to find me the inverse tangent of this right here, and you can see I get a negative value. So in other words, it gave me this down here, which was negative 75.81. Okay, so the calculator returned for me the inverse tangent angle down here in quadrant 4. I'm being asked to find the inverse cotangent, however, and it lives up here in quadrant 2. Now how do I get from quadrant 4 up here to quadrant 2? Notice that these are just rotated by 180 degrees, right? So if I were to add 180 degrees to this angle right here, it would rotate me right up to quadrant 2. So I'm going to add 180 degrees, and you'll see that this angle up here now becomes 104.19. Okay, so this angle right here is 104.19, which is theta, the inverse cotangent of that right there. So, although I didn't state it on the notes initially, you just want to make sure that you're in the right mode for what we're looking at, and I needed to be in degree mode on this one because that was what I was wanting to show you, was this rotation right here. So understand that when we take the inverse of our trig functions on our calculators, it returns for me the range, right? It returns the solutions, and it restricts them to what has already been programmed into there.